Exponential growth. Here is the formula. A stands for the initial value or the initial amount. So say you started, like in this example, you started with $1,800. That's your initial amount. You'll also see it called principal. The principal amount is what you start off with. R stands for the rate, and this must always be a decimal. Do not keep it as a percent. Change everything to a decimal. And T stands for time. So in this example, you invested $1,800. That's what you started off with. So this is your A value. And your value has increased by 7% each year. Each year you get 7% more money. So 7% each year, that is your rate. And you must change this to a decimal. So what would you guys put? Exactly. 0.07. Next, we're going to talk about the time. So find the value of the investment after 15 years. That is your time. So we have all of the variables we need. Let's plug it into the growth formula. So your initial value was 1,800. 1 plus your rate, 0.07, to the power of 15p. Go ahead and type that into your calculator and let me know what you get. Wait, this is money. Oh, no, we don't say point. 26 cents. There we go. Perfect. So that is how much our investment grew in 15 years with an interest rate of 7%.
Sorry.
Okay. Next, we're going to do exponential decay. This is the formula for decay. Notice we're subtracting the rate. A is still your principal amount. That is what you start off with. And remember, your rate always needs to be in a decimal form whenever you put it in the formula. So guys, go ahead and try this. Plug in your values and figure out how much your investment is worth after 9 years. Unfortunately, this is a bad investment because it's losing value. It's decaying. Did everyone remember to change the percent to a decimal? Perfect. What did you guys get? Wow. So they lost money. If the question asked how much money did they lose, what would you do? Yes. 12,000 minus 8,310. They must have invested in Enron. Next one. We're going to talk about compound interest. Compound interest occurs, and it's better than the other ones because it's calculated on both the principal amount and how much interest they received so far. So for example, say after a year you gained $1,000, say you invested $8,000, and a year later you have $9,000, they're using this value instead of the initial value. All right, so the formula is your principal times 1 plus the rate divided by n to the power of nt. P is your principal. All of these remain the same. This is still your rate. This is still time. The only difference is we have the variable n, and n stands for the number of compounds. How many times it's compounded? Number of compounds in a year. So guys, if I say I'm going to give you interest monthly, what would you would put 12 because you're basing it on a year. If I say days, compounding daily, what would you put? 365. What if I said weekly? 52. It's based on a year. Okay. All right. So let's look at this example. It says Laura deposited 12,000 into her account and it earns 0.08 interest, right? We're changing this to a decimal. And it is compounded quarterly. So what number am I going to put? 4. And then you want n times t as the exponent. So your n value was 4, and it says 5 years. So go ahead and type that into your calculator. Let me know what you get. $17,831.40. There we go. I'm going to let you guys practice this for a little bit. So we learned compound interest. We've learned exponential decay and exponential growth. Continuous compound interest. That is interest that is compounded continuously. That means it's always earning interest. So this is the formula. The principal times e to the power of r times t. P still stands for principal. Your r is still your rate. T is still time. E is a number approximately 2.7, right? All right, so let's look at an example. Suppose $800, that's your principal, and your key word is it's compounded continuously. That means you're going to need E, change 6% to 0.06, 0.06, and your time is 20 years. Go ahead and type this into your calculator. Guys, do not approximate E. Actually type in E so we get a most accurate number. All right, good job. Can y'all say it to me?
2,600 9 cents.
And 9 cents? Yes. There you go. All righty, guys. So let's do this example together. So we deposit $1,000 and it's being compounded monthly. So guys, which formula out of the 4 we learned today, which one am I using? And what's the compound one? P? R over N? NT. Okay. So this is the formula I have to use because it's compounded monthly. So 1 plus my rate is, change that percent to a decimal, so 0.04 over. Guys, if it's being compounded monthly, what should I write? 12, because there's 12 months in a year. And you put 12 out here and you multiply it by 7 because we want 7 years. Guys, go ahead and type that into your calculator and give me an answer. Good. Thank you, Lorraine. All right, guys, let's answer the next question. It says, how long will it take for the account to double? So if I want it to double, how much do I want? 2,000. So guys, that means my total needs to be 2,000. And this is still my equation. 1 plus, this is your rate. It's still compounding every 12 months. And we don't know the time. It says how long will it take. So we're solving for t. We do not know t. Okay. Is this okay so far? To double 1,000, it would be 2,000. So let's figure out how long it's going to take for my whole equation to equal 2,000. So let's go ahead and start solving. What I'm going to do first is divide this side by 1,000 and this side by 1,000. So that cancels out. What's 2,000 divided by 1,000? 2. All those zeros cancel. It's just 2 equals all of this. 1 plus 0.04 over 12 to the 12t. That's what we have now. We divided by 1,000. Now, after this step, guys, you are going to change to a logarithm. Change to a log. Look what I'm going to do. This is your base, correct? So this will be log. This thing is your base. So this will be 1 plus 0.04 divided by 12. And it's down there because it's your base. Your answer goes here. And remember, you write the exponent out here. Go ahead and change it to a log. So first you need to change it to a log. Now, second part, use your calculator. Plug this into the calculator. Plug all of this into the calculator. Let me know what you get. Thank you so much. You guys plugged this thing into the calculator and got, what was it? 0.291 equals, we're not done, 12t. Guys, this is back to Algebra 1. What do I do to both sides?
Divide by 12.
Yep, divide by 12. Go ahead and divide by 12 and let me know what time is. 17 years? You rounded? 17 point what?
3547.
3547?
Well,
What?
they rounded. Okay.
Okay, let's forget it. I'll just put it right there. Years. Thank you, guys. Alrighty, I'm going to have you guys practice the rest.